Hello, I want to talk right now about the overarching mechanism that we're going to see when we look at reactions of carbonyls, specifically ketones and aldehydes, with weak carbon nucleophiles. So we're talking about amines and alcohols. And so the mechanism that's going to happen is addition-elimination of water. We're going to add the nucleophile to the carbonyl, we're going to do a proton transfer, we're going to eliminate water, and we're going to get to either an oxonium ion or an iminium ion intermediate, and the fate of those intermediates will tell us what product we're going to get. In the case of the oxonium ion, we're going to end up forming a ketal or an acetal. In the case of an iminium ion, we're going to end up with an imine or an enamine. And so what I want to do is just work through how we get from our, in this case, ketone, and we should be clear, this can be a ketone or an aldehyde. Right? And we should be very specific. These are specifically ketone and aldehyde reactions. Right? These are not acid chloride reactions or ester reactions. Right? These are ketone and aldehyde reactions. And again, we're reacting with our weak nucleophile. And again, this is something where we talked about we can have things going forward or reverse. Right? And so if we want to go in the forward direction, it's key that we put in here that we're going to remove water. Right, and there are experimental ways to do this. Right, there are pieces of glassware that can help you do this. There are experimental tricks you can do. For us, we just have to write remove water. That's going to allow us to go towards the product. Right. Actually, I should make this a little more clear. Remove water to favor products. Right. And if you want to favor the reactants, you're going to add water. But what I want to talk about now is how you get to those intermediates, right? So it's clear what the mechanism looks like and how we can draw that out, right? And again, our nucleophiles here are going to be either an alcohol, in which case Z here is O, or it's nitrogen, in which case it'd be R2ZH or RZH2. So it's clear what's going on up here, right? So first thing we're going to do in all these reactions when we have acid, and again, this is an acid catalyzed process, we're going to protonate the carbonyl. That's the first thing we're always going to do, right? So we're going to protonate the carbonyl. Because again, in acid, we're going to have intermediates that are either neutral or positive, right? So we're not going to add straight to the carbonyl. That would give us an O- intermediate, which we can't form. And with these weak nucleophiles, they're not strong enough to create an O- intermediate. So we protonate it first, and then have the nucleophile add. That gets us to the tetrahedral intermediate, and in a pattern that we're going to see repeat over and over again. The next step we're going to do is a proton transfer. And again, proton transfer, we're going to move a proton from one electronegative element to the other. So we want to form water, right? We know this is addition-elimination of water, so this is our addition step. Then we do the proton transfer. And now we can eliminate water, right? And so we can form that Z to carbon double bond, water can leave, and that gets us to either our oxonium ion or our iminium ion. And again, if we want to favor formation of these things, we're going to remove water, right? Remove the water. That'll push the equilibrium toward the oxonium and the iminium ion intermediate, and that's how we're going to favor these reactions happening. So now we get to these species, right? And the key thing is what happens to them, right? So if you're the oxonium ion, another equivalent of the alcohol is going to add. And you're going to eventually end up forming a ketal. And chemists aren't great about ketal and acetal. They use those terms interchangeably. Usually you think about a ketal coming from a ketone, an acetal coming from an aldehyde, but we'll use those terms interchangeably. But that's going to enable us to get to structures that look like that, right? Where you have two single bonds to oxygen in place of the two double bonds to oxygen from the oxonium ion. So that's what the oxonium ion is going to turn into, right? The oxonium ion is going to turn into the ketal or acetal. And there's a separate video that we have that goes through the mechanism for all that stuff. So I'm not going to go through that in this video, right? If you have an iminium ion, and again, it can be from a primary or a secondary amine, right? That's going to enable you to go to, and we're going to have water acting as a base. And again, I know we said remove water here, but we generated water as well from the first protonation event, and we have to regenerate the catalyst. But water is going to remove a proton, and you're going to end up at one of the two possible products, right? And actually, only one arrow here, right? And water as a base is going to remove a proton, and you're going to end up with an imine if you remove the H from the nitrogen, or if you have two R groups here, you're going to remove an H from the carbon, and you're going to get to an enamine, right? And it's definitely important that we understand that the key here is you're going through these oxonium and iminium intermediates, right? You take the ketone, get to these charged intermediates, and then from those intermediates, you get to ketal, acetal, imine, enamine. And the goal that I hope we'll all get to is to recognize that even though these products, ketal, acetal, imine, and enamine, look different, they all go by the exact same mechanism, which is through formation of the oxonium or the iminium ion intermediate, right? And as a bonus, there's another reaction that's related to this, which is reductive amination. That enables you to go from the iminium ion intermediate to an amine. Right? And this is an amine synthesis, and there's a separate video on that. But it's important to recognize that all of these products come out of the exact same mechanism, at least the beginning of the mechanism, which is addition-elimination of water, right? And we'll continue to practice doing this mechanism and understand why we might want to make these different types of functional groups.